in which I requested the volume, and the volume should be in milliliter, but I did not mention it. So some of you wrote the volume in liter, and it was considered as wrong, but I will look at it and I will review that question. So I did not finish it because it will take me a long time now to go over all your answers and check the answers, and we'll see what to do about it. But I'll solve that problem, inshallah. All right. Also, I want to remind you that next 1 week from today, next Monday, we have the midterm exam, which will be face-to-face. So probably we will see you, inshallah, for the first time in the next Monday, inshallah. All right. So be ready for it. And in this midterm, it's already prepared and everything. In the midterm, that we are going to cover the chapter 1, 2, 3, 4, 5, and 10, which we are going to finish just now. So we are still having chapter 5. We're going to finish it, inshallah, this week. All right?
Doctor?
What?
With the midterm for them will be online or
لا ما هو اونلاين فيس تو فيس.
لا اللي عندهم اللي فيهم كورونا.
اللي عنده كورونا يتصل بشؤون الطلاب ويتصل يعني على برضه مسؤول عن الموضوع هذا، يرسل. انت ارسلت لي ولا لا المازني؟
ارسلت لك، بس اقصد شنو الاجراء المتوقع، يعني كيف بيكون الاختبار عشان اكون مستعد قبلها يعني. بس
ما تقرر، ولكن لازم تجيب عذر من شؤون الطلاب، لازم ترسل اوراقك لشؤون الطلاب.
رسلت اوراقي لشؤون الطلاب بس استناهم يردون علي بس.
ايوه رد، لما يردون عليك ارسل لي الرد اللي ارسله لك.
طيب تمام.
طيب غير حنبدا ان شاء الله الشابتر as I said. all right.
دكتور.
نعم.
افرج.
حق ايش؟
حق الكوز اللي راح.
4.5 من 10. ما حسبت بالضبط لاني ناوي اغير الحساب، فححسب المره الجايه ان شاء الله. All right. Bismillah ar-Rahman ar-Rahim. Let's continue with chapter 10. Chapter 10. What we are going to talk about is all right. Last thing I talked to you about is what I want you to know in chapter 10 in the energy. The energy of gas, any gas, is equal to 3/2 RT. The temperature. So if you know the temperature of the gas, you can tell what's the energy. Which R you should use here? You should use the R which is equal to 8.31 joule per mole. And you don't have to memorize this number. It's available in the periodic table. Is this clear? But I want you to memorize this equation. Very important. So you can measure the energy of any gas at a certain temperature by knowing just R. Also, if you relate this equation together, you will get to URMS. What's URMS means?
Root mean square.
That's what we want you to know. Root mean square speed. That's the how should you should read U. What's this equal to? It's equal to square root of 3. You must memorize this equation extremely well. We got this equation from this relation, but you don't have to know how. You have to know U, which is RMS, will be equal to square root of 3 RT over M. What's the 3 is constant? What's R?
Gas constant.
Is equal to what?
8.31.
8.31 joule. Don't forget joule per mole. All right, good. What's T?
Temperature.
And
Kelvin.
Kelvin. What's M?
Polarity.
Concentration.
No.
Molar
Mass.
mass.
No.
Mass. Gram per mole.
Whenever I should do that, whenever I draw the M like this is called molar mass. Molar mass. And from where you get the molar mass?
Periodic table.
Periodic.
But in this equation in particular, you should write the molar mass in kilogram, not in gram, so that you can get rid of joule with kilogram. So the unit should be kilogram. This and make sure that you know it. Now, let's very quickly, I want you to calculate URMS for oxygen gas at 0 degree C. Go ahead, calculate it very quickly. Don't forget, you have R, you have to change to temperature to Kelvin, but the mass, what's the mass of oxygen gas?
16.
No, O2. 32.
32, yeah. 16 multiplied by
divided by 1,000
But what unit we want?
kilogram.
kilogram.
Divided by 1,000.
I multiply by 10 to the power minus 3. 32 times 10 to the power minus 3 kilogram. That's the mass of O2. That's the molar mass.
It's equal 461.3.
Very good. 461.3.
Yes.
What's the unit? What?
Meter per second square.
It's a speed unit. Meter per second. Who got the same answer?
461.17.
Okay, 461 point. Actually, it's 461. I know it's 461, so it's good. Is this clear? I can assure you next week, inshallah, next Monday, there is at least one question asking you about this thing. So already you know one question. Don't forget to make the mass in kilo and the temperature in Kelvin, of course, and the R that you should use is the one with joule, which is available in your periodic table. Good. So from this equation, if you increase the temperature, what will happen to the speed?
It will
Increase.
It will increase. If it's 100, this is the average speed, this is the average speed, and this is the average speed, and this is the average speed. What will happen to the average speed as you increase the temperature? Increase. Good. Also, which gas you think is faster? Cl2 gas
Helium.
or H2 gas? Which one is faster?
Oh, the one has less molar mass
Why?
because it's in the denominator.
Because we are dividing by the molar mass. So yes, which one is faster at the same temperature, at same T? Is it Cl2 or H2?
H2.
Definitely H2. Exactly. So if you have three gases, helium, and N2 and Cl2. Which one is the fastest?
H2. Helium.
Helium. Why? Because the mass is 4. How about nitrogen? What's the mass of nitrogen?
14.
14.
14.
Times 2, yes. 24.
28. How about
28.
it's 35.45 and this is 71. So see, this is the average speed of helium, this is the average speed of nitrogen, this is the average speed of Cl2 at the same temperature. You must memorize the equation. Good. Next. If I want, we know that what's URMS equal to? Square root of what? 3
RT.
over
molar mass.
molar mass in kilogram. Right? Okay, compare the speed of gas 1 compared to speed of gas 2. Divide gas 1 by gas 2, and then you will get rid of 3RT, so it will be at the end. This is, and the M2 will go up and M1 will come down. And this is now, you can relate the speed of two different gases using only their molar mass. If you are talking about this, it must be the same temperature at constant T. Is this clear? You have to memorize this equation as well. You don't have to memorize this equation. What you need to do is really to memorize this equation, and you can derive this equation, but also better to memorize it right away. Is this clear? You notice here, gas 1 up, the molar mass is down. Gas 2 up, molar mass is down, the molar mass is up. Is this clear? Okay, good. Which is faster, helium atom or carbon dioxide?
Helium.
Why? What's the mass of helium?
Molar mass is less.
What's the mass of helium? Go to your periodic table.
4.003.
How about CO2?
49.
1.
44.
All right. Okay. If helium, I want you to tell me what is the U helium compared to U CO2. Give me an answer.
3.316.
What are you going to do? This is square root of what?
Square root of the molar mass of helium.
No. First.
Of carbon.
CO2 of carbon, yeah.
Yes, divide by
Helium.
The helium.
What's the answer?
3.3.
3.3.
3.3. Good. See, once you see here, you should know which one is higher in mass, helium or CO2?
CO2.
CO2.
So which one is faster?
Helium.
Helium.
Faster. So U of helium over U of CO2, should it be more than 1 or less than 1?
More than 1.
More than 1, because it must be more, its ratio, it must be more than 1. Is this clear?
Doctor,
Yes.
why don't we convert it to kilogram?
You don't have, well, very good question. Do we have to change it to kilogram?
No, because
no need.
unit will cancel.
No, the same unit.
Change it to kilogram, but what will happen?
Cancel each other.
Cancel each other. Because the unit is the same, because you're using here gram and gram, you can cancel the unit and it should be no problem. But if you are doing this equation, you must use kilogram because you're going to use to change the kilogram to joule. Is this clear?
Yes.
Doctor, always I have to put the great number up and small
No.
number down.
No, what's the ratio of FuCO2 to helium? What's the answer?
Now I have to flip it now.
Exactly. So it would be 4.003 divided by 44.01. Is this clear? I hope so. Now,
Doctor, the number we get, what is the benefit from it? Like, okay, we get this number and...
Good, very good. No, now, if the speed of helium is 107 meter per second, then what is the speed?
Divided by 3.
Speed of
32.
What is it?
32.
107 divided by 3.3 exactly. To know it's 32. So if I ask you what's the speed of any gas at a certain temperature, and I give you the speed of another gas, you can compare them by molar mass. Is this clear?
Clear, yes.
Now, two important words I want you to know very well: diffusion and effusion. Diffusion, what's the mean? Write the word diffusion. Diffusion. What's diffusion? If you have two gases like this, all right? One of them is purple and one of them is yellow. What will happen if you open the valve? You take the valve and open it. What will happen?
They will mix together.
It will mix. This mixing is called diffusion. Diffusion. All right? Okay. The rate of diffusion, okay, no, before this, rate of diffusion, and if you have two gases, this is the yellow gas, and the other side, this is gas, and on the other side there is what?
Vacuum.
What's the meaning of vacuum?
Means
Without
Nothing. And if you have an opening here, what will happen to the gas? Start coming to the vacuum, right?
the vacuum.
Right? This is called effusion. Effusion. I want you to memorize these two words. Very important in gases. Diffusion and effusion. Diffusion and effusion. Rate of effusion of helium compared to rate of effusion of oxygen, let's see. What's the answer? What's this equal to?
compare the two.
Effusion is related to what? To the speed.
Equal to the square root of
Exactly. This is equal
the molar.
to what?
The molar mass of oxygen over the molar mass of helium.
Which is, give me numbers.
32 over 4.0.
Exactly.
03.
With the rate of effusion. Clear? I hope so. This is called Graham law. Graham law. And it's relating effusion and diffusion, and it's actually related to the mass. One more time. Good. Now, last thing in chapter 10 that I want to talk about, and we will finish it. When we cold. What's this called?
General.
Equation of gas. Ideal.
Ideal gas law. Ideal gas law. Is this clear? Okay. When there is high pressure, very high pressure, or very temperature, then we are going to deviate. Deviate. What's the meaning of deviate? deviate. What? What's the meaning of deviate? If this is a straight line, you deviate if you go like this. Okay, so you are deviating from the straight line. This means you are not going in the same line. That's the meaning of deviate. All right? Same thing with the gas. The ideal gas is applied to gases, all gases. But when you have high pressure or very low temperature, then the gas will deviate from ideal gas law. Ideal gas law. Is this clear?
No, Doctor, again.
Okay. As I said, the meaning at first I wanted to know the word deviate. Very important word. Deviation, deviate. Deviate means if I ask you to walk in this straight line and you start walking, you are walking in the straight line, you are okay. But let's say one student start walking like this and then start going aside like this. Then what's he doing? He is deviating from this line. Deviate. Deviating. The same thing with the gases. If the ideal gas law, if this is the ideal gas law, then the gases, if this is the ideal gas law here, if the gas at a very high pressure or very low temperature, then the gas will not going to be ideal, start deviate from the ideal gas law. Clear? But as I said, this is we always apply for the gases the ideal gas law, always. But if you are in a place where you have, I tell you that we have extremely high pressure. For example, I have 1,000 atmosphere. Or I have very low temperature. I have minus 200 degree Kelvin. Oh, sorry, degree C. Minus 200 degrees C. Then you cannot apply the ideal gas law. You have to apply another law. All right? The other law that we're going to apply is called Van der Waals equation. I want you to memorize the equation, Van der Waals equation, which is deviation from the ideal gas law. Deviation from the ideal gas law. And this is the Van der Waals equation. It's also called the real, write this, real gas law. Do you call PV equal to nRT? What do you call this law?
Ideal gas law.
Ideal gas law. And what do you call this law? Real gas law. Is there any similarity between the two laws?
Doctor?
Yes.
Yes,
Shouldn't be
Side.
the ideal gas law is real gas law, right, Doctor?
What again?
The ideal gas
Yeah.
shouldn't be real gas. Consider as a real gas.
No, the ideal is even better than the real. Okay. The real gas will be at low pressure and I mean very high pressure and very low temperature only. But this is the ideal gas law, PV. See, there is a difference. There is a similarity. PV equal to nRT. PV equal to nRT. But what did we do? We add some factors to it.
Do you have to remember the law?
Yes, yes, you have to memorize the real gas law. What's the other name for this law?
Van der Waals.
Van der Waal equation. Van der Waal equation. Okay. What? Of course, everybody knows what's P.
Pressure.
What's the V?
Volume.
Volume.
nRT. Of course, you know this is moles, R and T. What is V here?
Volume.
Vol.
Volume. Very good. What is N here?
Moles.
Moles. Exactly.
No.
What is N here?
Number of moles.
Mole also. So we will need the mole to put it in so many places and the volume. What's the only thing that you don't know here?
A and B.
A and B. A and B are constant. These constants are related to the gases. You don't have to know anything about these gases. These are the gases and these are the constants. Don't memorize anything. Don't even look at this table at all. But the A and B, if I'm going to give you this equation, I will give you the A and B. For example, if we are dealing with helium, this is the A for helium and this is B for helium. If it is with, for example, CO2, this is the A for CO2 and this is the B for CO2. Don't memorize these numbers. I will give it to you. I want you to memorize this equation, which is Van der Waal equation. Is this clear? All right. Yes. With this, actually, we finished chapter 10. I hope you got it. And we're going to move right away to chapter 5 because we are already late. So we're going back to chapter 5 after chapter 10. And now, what's this chapter 5? Just a second. Okay, chapter 5. What's the title of chapter 5?
Thermochemistry.
Thermochemistry. What's thermo means?
Heat.
Heat and chemistry. So what's this? This chapter is going to talk about
Energy and heat.
Heat relation between what? Heat and chemistry, or energy and chemistry. Exactly. All right. So we're going to relate heat and chemistry. I hope it's clear. Good. Now, yeah, energy. What's energy? Energy, we have two kinds of energy. Everybody knows this. Energy, we have two kinds. What's the first one? It's called kinetic energy. The other one is called
Potential energy.
Potential energy. Very important. Potential energy. All right. What's the difference between kinetic energy and potential energy? Kinetic energy is related to what? Motion. Speed, motion. Kinetic energy is related to motion, while potential energy is related to position, place. Is this clear? So, kinetic energy, everybody knows from physics, simple physics, what's the relation between energy and speed? You know this equation, right?
Yes.
What's energy, kinetic energy, equal to what? Half
mv squared.
What's M?
Mass.
Mass. What's the U square?
Velocity.
Velocity. Don't forget this. Okay. SI unit. What's the unit for energy?
Joule.
Joule. Exactly. What's the unit for mass?
Kilogram.
Exactly. What's the unit for speed?
meter per second.
second square.
But meter square per second square. Why I'm writing meter square per second square? Because it's square here, right? I want you to know this relation and keep it in your mind all the time. So if I have joule, I can write, if I have 5 joule, this is exactly equal to what? 5 kilogram meter square over second square, right? Keep this relation in your mind and you can remember it. Don't forget it from this equation. 1 joule is equal to 1 kilogram meter square over second square. So if I want to change unit or get rid of unit, I can change joule to this relation. Very good. Good. Thermal, as we said, this energy is related to what?
To motion.
Motion. Motion. Good. Thermal energy. Thermal energy is the atom, when the atoms are moving, This is an atom. The energy of the atom, when it's moving like this is called thermal energy, related to the motion of atoms or molecules. So thermal energy, is it, from now on, thermal energy, we're going to call it Q. Q, all right? And is it kinetic or potential energy?
Potential.
Kinetic.
Why is it potential? Why is it kinetic?
Because with the movement.
Yes, as I said, thermal energy is related to the motion, random motion of atoms and molecules. Thermal energy is random motion. Read this, random motion of atoms and molecules. So is it kinetic or potential?
Kinetic.
Why?
Because there is movement.
Motion. There is motion related to movement or motion, so it is kinetic energy. And we're going to call it Q. Thermal energy, from now on, we will use the letter Q to represent it. Clear? Good. What will happen to the Q if you change the temperature?
It will increase if the temperature increase.
Exactly. So why is it going to increase with the temperature increase? Because there will be more motion. Clear?
Clear.
Next, the other energy is called potential energy. Potential energy. Potential energy is related to what?
To position.
So that's why usually we write 2 lines like this, and we say if somebody is standing here and I move him from this place to this place. So what happened to his energy?
It will increase.
How can you take this person from here to here? You have to put energy. You have to, if I put, for example, this box here. If I put this box here and I ask someone to take it up here, what's he going to do? He will go himself, take the box and put it up, right? And he will put his energy. So you need to put energy for this system to go up, right? But if I have the box here and, okay, and I take this line out, what will happen to the box?
Fall down.
Will fall down by itself. And what will happen to the energy? The energy
It will lose, will convert to kinetic.
All right. So, yeah, it will change to kinetic or whatever, but it will come out of the system. So this, you need to put energy to take it from here to here. Here, if you go from here to here, the energy will come out of the system. That's called potential energy. chemical energy, and the bonds between the atoms and so on are all potential energy. Chemical energy, all the things related to the attraction between the bonds and so on. So, for example, if you have COO, the chemical energy is related to the bonds between the molecule. This bond and this bond, these are all related to chemical energy. And chemical energy is a potential energy. Clear? Any question? The other type of potential energy is electrostatic energy. And what's electrostatic energy? Is the energy if you have two magnets. This is magnet. What will happen if you put these two magnets together?
Attract each other.
And what energy that will take place between them? It will be electrostatic energy. All right? And when they attract each other, is the energy going to come out, or you need to put energy to make it come together? Yes?
It's need energy.
No. If you put two magnets, imagine you have two magnets and put them very close to each other and you take your hands away, what will happen?
Again,
Touch together.
They will attract each other, right? Without your hand, without your help. Good? This means the energy will come out. It's like dropping the box. Right? So if you put these together close to each other, they will attract each other and energy will come out. So they were like this. They were at higher energy and when they come together like this, they will be at lower energy and energy will come out. Is this clear? This is called electrostatic energy. Electrostatic energy, for us here, this is physics, but for us here is the same thing with if you have two ions, for example, Na plus and Cl minus. What type of energy will become between them?
electrostatic يعني.
Electrostatic energy. Why? Because they will what?
ionic.
Attract each other. This is like magnet, exactly like magnet. So because they are ions, they will attract each other, to make the ionic bond. Exactly. Clear? Okay. This energy, electrostatic energy, is related to Q1 times Q2 divided by D. What's D?
Distance.
The distance between.
It's Q1 and Q2 is the charge. Clear? So if I have sodium with chlorine, or I have Mg2 plus with chlorine, if I assume the same distance between them, which one will have higher electrostatic energy? First one?
The second one.
Second one. This one will be higher. Why? Because if the distance is the same, the Q1 here is 2, Q1 is 1, Q1 here is 1 and 1. Clear? Very good.
طيب الإشارة يا دكتور بتكون بالماينس فبتكون
What again?
هنا في الكيو 1 وكيو 2 ناخذ الإشارات ولا بدون إشارات؟
بالإشارات طبعا لأنه actually we will talk about الإشارات الآن بس yes you take it with sign. with the negative sign, because when energy come out, it should be negative. So this is coming out and it should be negative. Yes, it is with this sign. We'll talk about the sign in a while. All right, good. Okay, good. Yes, now, kinetic and potential energy. Okay, all right. What's the law of conservation of energy?
P يساوي Q
The energy of gain is equal to the
That
loss.
energy change but do not vanish.
Exactly. Do you know the law of conservation of mass? What's the law of conservation of mass?
The
mass cannot be created, or vanished, nor destroyed. The mass is there. Law of conservation of energy, same thing. Law of conservation of energy says that you cannot lose energy from one form to the other, but you cannot lose it. Is this clear? So you can change potential energy to kinetic energy, potential energy to kinetic energy, or you can change kinetic energy to potential energy, and so on and so forth, but you cannot lose it. Good. Okay, next, let's talk about what's the system and the surrounding. System is whatever you talk about. So you can talk about this box. If you are going to talk about this whole box here, then what is your system? Your system is this box. Where is your surrounding? Anything around it, surrounding. But sometimes, for a chemist, I always want to talk about the chemical reaction. For example, if I have A plus B goes to C plus D, what's this? This is a chemical reaction, right? I can make my system is the chemical reaction. This chemical reaction is my system. Then what is the surrounding? Anything around it is considered to be surrounding. Surrounding means around, anything around or حول, يعني حول system. So the system, you decide what's the system. In this case, you said, no, I want this box is my system. Where is the surrounding? Anything around it is the surrounding. Somebody says, no, I want to study this system in which I have a chemical reaction in this beaker, okay? And there is lots of water here. But I want to study this reaction. I want to do this reaction in this system. Where is my system in this case? Hello? Where is my system? The chemical reaction itself. This is my system. So where is the surrounding?
The water.
The water is the surrounding. The air outside is also the surrounding. The air here around is surrounding. The box is surrounding. Anything is surrounding. Clear? So everything around it will be surrounding. But so what do I mean by system? You decide your system. You define your system, and then you make the surrounding around that system. Clear? Good. Okay, now heat is considered, as I said, we're going to use the letter to represent it. What's the letter I told you already?
Q.
Q, don't forget it. Heat is Q. And is it kinetic or potential energy?
Kinetic.
It's kinetic energy. Heat is kinetic energy. And we measure it by temperature. All right? So we measure it by temperature. لما واحد منكم تكون حرارته 40 ايش معناته؟ حرارة. We have to, he has to see the doctor, it's too dangerous. We measure the heat by temperature. Is this clear? And the heat is potential kinetic energy. Heat is kinetic energy. Q, don't forget it. Okay, so this is called thermochemistry. Thermochemistry is study of heat. When we study thermochemistry, we are studying the heat, which is Q, the heat transfer. Okay, now chemical reaction are potential energy. Chemical reaction are potential energy. When you have H2O liquid goes to H2 gas plus O2 gas, this is potential energy, and the energy will go, you need to if you react H2 gas, if you take hydrogen gas and have a flame with oxygen, there will be big explosion and water will be formed. This is chemical reaction. This is chemical reaction, H2 plus O2 to give you H2O2. The chemical reaction is potential energy. This is where the hydrogen and the oxygen before the reaction, when you react them, they will come down the energy and you will make water, and the heat will come out. There will be big explosion and heat will come out of the system. So because of the conservation of mass, because this was at high energy, come down and the heat will come out of the system. My system now is, this is my system, okay, the chemical reaction, and when I make this reaction, the energy will be coming out of the system. Is this clear? Okay, so as we said here, Q, which is heat energy, is related to kinetic energy and its temperature. You measure the temperature or you find what's the heat around. When you have chemical reaction, it's a potential energy, and either you go up or down, it depends on the chemical reaction, and if it comes down like this, the energy come down, then the heat will come out of the system, and we call this process exothermic. You have to memorize the word exothermic. Okay, I want someone to explain to me what's the meaning of exothermic reaction.
Getting off of the system.
Have a reaction in which the reactants are what? This is the reactant at higher energy than
release
product. The energy of the reactant is higher than the energy of the product. What will happen if you go from reactant to product?
Giving off energy.
You will take, we'll take out energy to come out of the system. And this, what's this process called?
Exothermic.
Exothermic. If I take, okay, if I take water, oh, you have it here. Okay, now, if I take water or HGO solid, and I take it to a chemical reaction, the energy of HGO is lower than, this is lower, this is also, this is reactant, and this is product. So which is higher energy? The reactant or the product? Product. How can you go from the reactant to the product? How can you take something from down up? You need to
raise the temperature.
To add energy, you have to put energy. Is this clear? And this is, we put energy. You need to come and put energy here to go from down upward. And this is now called endothermic. Endothermic. So you need to put the energy to the reactant to make the product. But this one, you need to, when you make the reaction, the product will give you reactant. Reactant will give you product plus what? Plus energy.
Doctor.
Exothermic. Exothermic. But in the other one, you need to put the energy with the reactant to make the product. This is called endothermic.
Doctor.
Yes.
No, number one is the exothermic. Yeah. This means how we can get a product without energy. We need energy.
You get the product without energy. If you mix H2 with O2, you don't have to put any energy. There will be a big explosion. Be careful. Don't be very close to this reaction. All right? You need something to start it. تحتاج ماتش ولا نار بسيطة ولا أي شيء حار على أساس يبدأ ولكن لما يبدأ التفاعل the energy will be so huge. Don't be close to this thing.
Okay.
Okay.
من where this energy were created?
Because of the chemical energy. لأنك غيرت الchemical energy الروابط إلى حرارة. You remember we said that we have في chemical. هذا جات من الكيميكال انرجي. الحراره اللي جات تحولت الى thermal energy which is Q, heat.
So it's a transfer from potential energy to
what again?
Chemical energy. It were potential energy.
Potential energy is in this
from
case chemical reaction, chemical energy. You're changing chemical energy to heat. That's what you're doing here. Or no, in here the reverse. You're changing here. You're changing chemical energy. Here, chemical energy into heat. But here, you're changing heat the other way. In this reaction here, you're changing heat. You're adding heat to the reaction heat to make it to chemical energy. Okay, I hope so. Good. As we said, the energy will be used in this unit. Calculate the kinetic energy of helium atom moving at 125 meters per second. What's the first thing you should do? Go to the periodic table. You'll find that helium about 4 AMU. Okay, I want you to find the energy. What's the energy?
Half times the mass.
Half mass u square speed. You have the speed 125 meters per second. But in order to have the unit in joule for the energy, what's the mass should be?
Kilogram.
How can you change it to kilogram?
Divide by
10 to minus 3.
This is AMU, not gram. What's AMU? 1 gram.
by 760.
Clear? How can we? Now calculate the mass of helium in kilogram. Go ahead. So you have to change AMU to gram by dividing by Avogadro's number. Don't forget this. Very important. And then change the gram to kilogram. Go ahead and calculate the mass of helium. And then calculate what's E.
Is it 5.19 multiply 10 to the power minus 23?
No.
I got the same number.
Yes. You're absolutely right. 5.19, exactly. 5.19 times 10 to the power minus 23.
Minus 23.
Exactly. All right. Very good. Okay, next. How much greater the now we have electrostatic attraction. What's the law of electrostatic attraction?
Q over T
Q1
multiplied.
Q2 divided by D. Proportional, not equal. All right, very good. If you have attraction between an electron and nucleus containing 3 protons and another nucleus containing only 1 proton, which will attract the electron stronger? Assume the same distance. Distance is the same. You have in the first one
3 protons.
3 protons, sir.
What's the relation between them? What's the relation between I'll call it E1 and E3, which is E1 means the attraction of 1 proton, and this is attraction of 3 protons. Which one is going to be bigger?
With the 3 proton.
Okay, how much bigger?
3 times.
By 3.
3 times. So E3 equal to 3E1. Is this clear? Because I'm going to multiply 3 times 1 in the first one, in the E3, and only 1 by 1 in the other one. Exactly. So yes, the relation would be 3. I hope this is also clear. Now, one unit that it's available for you in the periodic table, but I want you still to memorize it. There is another unit that we use for energy. The unit that we use for energy is joule, but there is also a very famous one, which is calorie. Calorie. Okay? A calorie is equal to 4.184 joule. I want you, this is available in the periodic table in the exams, so you don't have to memorize this number, but I advise you to memorize it. Okay? Don't forget it's 4.184. It's available for you, but still memorize it. Calorie. There is another, which I don't, I mean, sometimes when they put usually C as a capital like this, then they mean kilocalorie, or calorie is 1,000 calorie. And that's usually now what they use when they talk about calorie that you consume during a diet or anything like that, they use this calorie. But don't worry about it. What we care about is the small, this one. I care about this. You must memorize this relation. And as I said, I will give you this relation in the exams or in the periodic table. It's available. If you have a periodic table with you now, look at it. The units that we give you, one of them is the calorie is equal to 4.184 joule. Good. It function. When we have a system, we call this system is open and not insulated. Not insulated. This system is closed but not insulated. Not insulated. This system is both closed and insulated.
Insulated.
What's the meaning of insulated? There will be no heat coming out because it's insulated. There is no heat. No heat can come out. In the open system, both mass and heat can be lost. يعني شوف هنا في mass vapor is coming out. This means the mass is lost. You will lose mass lost, and heat also lost. In the closed system, what do you lose?
Heat.
You lose heat. But how about mass?
No loss.
No mass loss. How about in the insulated?
No heat,
no loss, no heat, no mass. Clear? Okay, good. Next, first law of thermodynamics. This is first law of thermodynamics. You must memorize the name, very important, more important than the equation itself. All right, what's the first law of thermodynamics? It says that the U, which is total energy, internal energy, okay, cannot be destroyed or lost. Anything available in the system, if you change any energy, by the way, U is called internal energy. Okay, if you have a system, the whole energy of this system, the whole energy is called U system. This is the internal energy of the system. Okay. If anything happened to it, if you lose it, or if there is any changes, for example, if you heat it or absorb energy or anything, there will be change in this energy, right? This change energy, we know by the law of conservation of energy, no energy can be gained or lost from nowhere. It can be also only transfer. So all the energy that you're going to lose or gain in the system must go to the surrounding. So the total energy that you lose or gain in your system, you will lose or gain in your surrounding, and the total energy of both of them must be zero. That's the first law of thermodynamics. We can say it by equation. This is the equation: delta U surrounding plus delta U system. So delta U system equal to what? Zero. Or we can say it by version that the other way to say the first law of thermodynamics: no energy can be what? Can be
lost.
Created
or destroyed.
Created or destroyed. It can be only transferred, right? It can only transfer from one place to the other. But this is the law of first law of thermodynamics. No energy can be created or destroyed. It can only be transferred. And that's why if you have anything change in the system, it will be transferred to the surrounding. The total energy will be zero. No energy will be created or destroyed. I hope this is clear. And so delta U of the system must equal to delta U surrounding. Good. Delta U, of course, we know that delta U, this is from math, is U final minus U initial. Next, delta U of the system can be calculated by this thing, which is Q plus W. Q is, we defined Q before. What is it?
Heat.
Heat.
Thermal. What? Thermal energy, or it's what? Heat. Thermal energy or heat. And W is called what?
Work.
Work. Work. All right. Very good. So this is, you must, this is also another way to say the first law of thermodynamics. Delta U, first law of thermodynamics. Delta U is equal to Q plus W. Q plus W. Good. Next. Now, look at this very carefully. If this is your system, all right, and this is okay. No, let me see. If this is your system, and I add heat to it, heat, I have it from surrounding, so this is surrounding. Surrounding, and this is system. If the heat goes from this surrounding to the system, we will give it positive value. Always. If the system give heat, this is the system again, give heat to the surrounding, it will be, Q will be negative. So Q will be positive when heat goes from where to where?
Surrounding to the system.
Absorbed by the system. This means it goes from surrounding to the system. So it is absorbed. So we will give it plus. If it is released, come out from the system to surrounding, we're going to give it what? Negative. Negative. Clear? All right. Now, if the work is done by the surrounding on the system, example, now this is your system and this is your work, this is your system here, and this is a piston. If you put pressure here, what the work is done by what? The work is done by surrounding on system, because you are putting pressure on the system. Clear? The W will be plus. If the work done by the system, if this system is expanding and doing the work on the surrounding, then the W will be what? Negative. So work done on system, is this going to be positive or negative?
Positive.
Positive, because it's done on system, by surrounding. Okay, done by system, it will be negative. Clear?
Doctor.
Calculate the overall change in internal energy in joule for a system that absorb. What absorb means?
It's heat.
There is no loss.
Is it plus or minus?
Positive.
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 Because heat absorbed by the system or endothermic process.
Absorbed by the system, so it comes from the surrounding to the system, and the system does work. The system does work. W is going to be positive or
Negative. Negative.
Because it's done by system and surrounding. Clear? So what's delta U? Q plus W, and what's the value? Plus 188 minus 141. Is this clear? Any question? Very important table. I mean, you have to memorize it. It's very easy. You don't have to memorize it. You have to understand it and understand it very, very well. Make sure you understand it. Okay, just a second. A system like this, any system, if we have a system like this, if this is a reactant and this is product, okay, when the reactant goes to product, potential energy, what will happen to the heat? Q will come out.
Increase.
Huh? Is the Q here going to be positive or negative?
It depends.
Negative.
It will be negative.
Lost.
It will be lost, so it will be negative, exactly. But if you have the reactant here, and you have product here, and in order to go from reactant to product, you need to put energy from the surrounding. What's Q will be in this case? The Q for this, the Q value for this will be what?
Positive.
Positive. Is this clear?
Yes.
So, good. Now, W, that's very important now, W okay, W is equal to minus P delta V, minus P delta V. P, pressure. And what's V? What?
Volume.
Volume. So W equal to minus P delta V. We know that delta U is equal to Q plus W. So delta U is equal to what? Q minus P delta V. Okay. If there is no change in volume, then what will be the value of delta V? No change in volume. What's delta V?
Zero.
Zero.
This means zero. If delta V is zero, what will be P of delta V?
Zero.
Equal to zero.
Zero. And in this case, the whole thing will be zero. And then we call this Q, we call it QV. What do you mean by V?
Constant volume.
Constant volume. Then Q will be equal to what? Delta U.
Doctor?
Yes.
Can I replace the B delta V by N R delta T?
No, this is not, we're not talking about gases.
So it's not ideal gas equation.
Okay.
Okay.
You can calculate it from NRT if it's ideal gas, but in this case, no, we're talking about only the volume. Okay? Okay, good. Also, when P is constant, pressure is constant, then QB, this is QV means volume is constant. QP is when pressure is constant. P equal to delta U plus delta V. From here, same equation, but in this case, this does not equal to 0. So QP equal to delta U plus P delta V. Now, when we have a system, we're going to introduce a new system which is called enthalpy. Enthalpy. H. H is actually H equal to QP. Then delta H equal to QP. So when we have the Q in constant pressure, which is equal to delta U plus P delta V, we have another name for it here. We also call it delta H. Delta H. And I want you to know this equation. QP equal to delta U plus P. And what do you mean by P, delta QP?
Constant pressure.
And what's delta H in this case? The name, you must memorize the name.
Enthalpy.
Enthalpy. Enthalpy. All right? Okay. I will stop here, but before we leave, you must memorize this. I'll take the attendance, so wait 1 minute for me.
دكتور بالنسبة لوضع الاختبارات أتمنى دكتور شو اسمه يتغير الخيارات.
ايه
لأن بعض الأحيان أخاف تروح درجة ولا كذا بس عشان significant figures ولا غلط في الحسابات ولا حاجة كذا بسيطة يعني ما لها داعي تغير الدرجة كلها.
والله يا
اي والله فعلا يا دكتور صراحة جدا صعب طريقة الاختبارات كذا.
يا دكتور كيف صاير؟
للأسف يعني unfortunately فيه غش كثير في المالتيبل تشويس.
طب دكتور الأرقام تتغير من كل من شخص لشخص مو مشكلة. تتغير مع التشويسز يعني عادي.
نفس ما تغيرها في هذه يا دكتور.
ما فهمت كيف غشت
خلاص. لأنه صراحة إنه فاينل أنصر وما في خطوات، يعني الواحد يجيب درجات جدا سيئة في الكوز كذا يا دكتور.
صح دكتور. برضو بخصوص هذا اللي هي الفواصل، أنت قلت لنا نكتب بعد الفاصلة بخانتين، بس برضو قلت لنا دونت أبروكسيميت، فأنا حطيت نفس ما هو بالحاسبة، يعني حتى لو كان في رقم بعده يمديني أقربه ما قربته. بالأخير يعني أعطاني 4 من 10.
يا شباب الآن فتحنا الاتندنس، رجعنا ادخلوا وسجلوا الحضور. لما أقول لك دونت أبروكسيميت
يا دكتور
ما في رابط دكتور.
أرسلته لكم الآن.
اللينك ما وصل شيء.
والآن
وصل يا دكتور.
وصل
بسرعة تفضلوا. هذا لكم.
ما لقيت دكتور الرابط مو طالع.
نعم
الرابط مو طالع عندي يا شباب. في التيم مو في المحادثة الحين.
شاذ 60.
هذا أرسلته. أدخل الواحد بس الأخير. يلا الثاني مرة أرسلته وعلى التيمز. يا شباب لما أقول لكم في الكويز لا دونت أبروكسيميت، يعني لا تقول لي إن وزن الكربون تقريبا 11.5 أو 12، خلينا نقول 12.01، لا استخدم 12.01. هذا اللي أقصد. بس لما توصل للجواب النهائي يطلع الجواب 12.588 هنا، وأنا أقول لك خلي 2 ديسيمال فتكتب لي 12.59. فاهم قصدي؟
ما فهمنا كذا يا دكتور، احنا فهمنا شيء ثاني.
عشان كذا
طيب عشان كذا نقول احنا نبغى الخيارات، يعني اذا اختلفت الارقام في الاسئله بتختلف اكيد الاجوبه، ما يمدي غش.
ايوه فعلا يا دكتور. يعني صراحه
يعني دكتور يعني والله حرام، يعني انا ذاكرت وتعبت يعني وحليت متاكد من حلي كله، بالاخير نقصت على الشغله هذه.
دكتور ايام مثلا الكوزات العاديه لما يكون حضوري على الاقل على الحل راح اخذ درجه حتى لو الاجابه النهائيه غلط. يعني مثلا حليت 5 خطوات كلها صح، اخر شيء الاجابه النهائيه حليتها غلط او علشان ديسيمال او حاجه زي كذا يروح علي السؤال. لكن لما يكون خيارات على الاقل اذا حليت اعرف ان هذا الخيار الصح، بس مثلا تكون اجابتي 12.92 والخيار الموجود 12.91 اعرف انه هو، بس اني غلطت في حاجه تقريب وما تقريب وشغلات زي كذا.
لا انا زي ما قلت لكم لا تقربون، يعني استخدموا الارقام اللي موجوده عندكم زي ما هي. قربوا مو قربوا، في النهايه سوي
بس
راوند.
هذا بيضيع جهده دكتور اذا انه غلط على فواصل، ضيعت شغله.
فعلا يا دكتور
احنا
الواحد يحل
مشكلتنا بس
سؤال كامل في النهايه ياخذ زيرو.
كبير حاجه اسبوع كامل مذاكر على كويس عليه 1% بس.
احنا مشكلتنا ان ما كانت واضحه من البدايه فقط يا دكتور.
للاسف يعني زي ما قلت لكم الاول الحقيقه.
لا مو سالفه ما هي واضحه، هي واضحه، لكن المشكله ان خطوه واحده ممكن تضيع عليك الناتج على رقم واحد بعد الفاصله ولا رقم واحد من 1000.
ليش؟
لانه ممكن
هذا
واحد
اللي يصير يا دكتور.
غلط ماشي خطواته صح، ما قلت لك ماشي خطواته غلط، ماشي خطواته صح، لكن حتى مو غلط في
اذا الخطا في فاصله واحده
في الاجابه، ممكن غلط في خطوه بعدها شو اسمه ما كتب الجواب من طول الوقت ويقرب من 100 من 100 وفي الاخير اختلف 1 من 10 1 من 100. هذا هو السبب، عشان كذا انا بخيارات مو سالفه احنا فاهمينها، بس الفاينل انسر ضيع جهد الريتن. يعني الريتن ابرك من احنا نحل فاينل انسر صراحه.
صحيح.
على الاقل باخذ درجه
على الاقل في باص الكويت ولا شيء يا دكتور.
طيب شوف هنا في طريقه ثانيه. المشكله زي ما قلت لكم يا شباب unfortunately تعرفوا كم المعدل حق الكويز الاول؟
الكويز الاول يا دكتور ما يقاس عليه لانه سهل يا دكتور، شابتر يعني معظمها اشياء عارفينها فما يقاس عليه. يعني اتوقع لو انك سويت كويز في شابتر الحين وخيارات مستحيل الافرج يصير نفس الشابتر.
الشابتر 4 اللي فات لو تحط فيه خيارات وكل الافضل ما حد ممكن ما حد يجيب فل.
صح
دكتور اذا ارقام مختلفه ما حيقدر يغش، كيف بيغش؟ بيغش غلط اصلا.
هو اذا مالتيبل تشويس صعب. المشكله نتكلم عن هو ما اقدر اسويه، السيستم ما يسويه الا اذا ارقام مختلفه بالطريقه اللي سويتها لكم.
يعطيك العافيه يا دكتور.
في دكاتره يسوون كويز يا دكتور ترى خيارات ممكن لو تستشير منهم شو اسمه يعلمونك، لان في دكاتره يسوون خيارات وارقام مختلفه الكمبيوتر نفسه يغيرها من حاله.
وممكن دكتور يكون في طرف ثالث زي ما كان في الماث والماث 101 و102 كانت تختلف الاختيارات وتختلف شو اسمه يختلف السؤال نفسه، يعني تختلف من كل شخص لشخص وعادي يحط اختياري وما في
ترتيب الاسئله او شيء زي كذا.
يا دكتور في طريقه ثالثه بعد. احنا في الفيزيك معنا المدرس يقول اكتب روتين وصور الورقه حقتك.
ممكن بس
ممكن برضه دكتور ان احنا نصور لك الحل وخلاص يصير تصحيح كانه حضوري على الخطوات.
يا دكتور انا كان عندي نفس النظام ده الصراحه الترم الماضي ومره ما نفع. يلا افتح المحاضره من النت اللي عندي. اي حل بالله غير ذا الحل.
طيب
احسن شيء تخلي اختياري يا دكتور وتشوف لك برنامج ولا شيء يغير الارقام ولا اي شيء، بس انت تكون اختياري.
اشوف
الجامعه اظنها توفر البرامج دي.
الجامعه هذا هو احنا نستخدم برامج الجامعه هذا الموجود.
لان الترم اللي الترم اللي فات في الماث كان الاسئله كويزز خيارات والارقام تختلف من طالب لطالب.
اوكي اشوف انا بس
دكتور
ما تقصر يا دكتور.
الله يحييك
دكتور عندي سؤال عن الدرس اليوم. هل في مجال الكلاس الجاي؟
اوكي خلاص
يعطيك العافيه يا دكتور.
وياكم مع السلامه.